Howdy, this is Mr. Potter, and welcome to day 11 of our logic lessons. Today, we're going to be talking about two-column proofs. These are ways that we prove arguments that are going to be different from the way that we proved arguments so far. You may remember that we have been using truth tables, and we've been using the fact that an argument is really an implication, and we change an implication to a conditional and prove that it is a tautology. A two-column proof is slightly different from that. In a two-column proof, we want to do it in a more concise way, because some of these truth tables can get really large. If I have a truth table that has 4 statements in it, I have 16 rows in that truth table. I'll often end up with more than 10 columns, and it just takes up a whole lot of space. But a two-column proof is a more concise method of proving arguments valid. And there's a couple of things I want to talk about here. First, the fact that it's more concise doesn't necessarily mean that it's going to be easier. There is a step-by-step process that we'll be following, but this is going to be a little trickier than we're used to, and that's why we stress so much memorizing the logically equivalent statements that we've talked about. For example, contrapositive, double negation, De Morgan's laws, as well as the arguments that we talked about in our previous lesson with modus ponens, modus tollens, and hypothetical syllogism. So the fact that it's going to be smaller doesn't mean it's going to be any more easy or hard. It's just another process that we have. The second thing is this key word here. I can only prove an argument is valid. It's very, very difficult for me to prove that an argument is invalid using a two-column proof. It's not something we're going to talk about in today's lesson, but we will touch upon it in a later lesson. So, I want to talk about what I'm talking about with regards to a two-column proof. So, in a two-column proof, of course we're going to have two columns. One labeled statements, and one labeled reasons. And in a two-column proof, we list the statements we know that are true in this left column. So I'm going to list things that I know are true 100% of the time. And in this other column, I have to give reasons why I know that they're true. Now, the reasons could be something as simple as a premise, the fact that it's one of our original statements in our argument, could be using the rules of a conjunction, a disjunction, or a conditional when we know something happens to be true. It could be one of our logically equivalent statements, because logically equivalent statements have identical truth outcomes, so they're true at the same time. It could also be an argument, because we know that the argument, if we've proved modus ponens or modus tollens or hypothetical syllogism, the arguments are going to be tautology, so they're always going to be true. Now, it's really key that we talk about this. We talked on page 11 of our textbook, has a list of the logical equivalences that we've been using. De Morgan's law, denying the antecedent, denying the consequent, double negation, contrapositive, statements like that. And on page 23, we talked about modus ponens, modus tollens, hypothetical syllogism, and theorem A. So we're going to be pulling from these, both in today's lesson and in the future lessons, for our justifications. That's where these justifications are going to come from predominantly. So, I want to go through the process. It's a very simple step-by-step process. And the first thing that we're going to do in our two-column proof is to list all of our premises. Of course, we've talked in the past few episodes about how we list premise 1, list premise 2, list premise 3 if we have it. And they come from the sentences that we're reading. And we're looking for those key words, those if and then words, or the and, or an or if and only if. That's what we use to list our premises. 2, we take the conjunction of the statements. And of course, the reason that we take conjunctions is because they're implications. And an argument is an assertion that the conjunction of two or more statements, called premises, implies another statement called the conclusion. So the conjunction part comes directly from the definition of arguments. And of course, we talked in our last episode about modus ponens, modus tollens, or hypothetical syllogism. These are three arguments that we see so often. They're so prevalent in logic that we end up naming them just to say, oh, that's a modus ponens argument, instead of actually having to prove using a truth table. And step 4, this is the step that we have to do. If we don't reach our conclusion, we have to keep going. So we're going to be repeating steps 2 and 3, step 2 and 3, step 2 and 3, until we actually get our conclusion as one of our statements. The idea is these statements over here are things that we know are true. So if I come down here to step 7 and I end up with my conclusion, and I can give a justification, modus ponens, most tollens, hypothetical syllogism, then I know this has to be true and it's valid. So this is the 4-step process that we have for completing a 2-column proof. So what I want to do in this episode is I want to go through a couple of sample proofs. One very basic one, and one that's a little more complicated. So for our first argument, I've got, if it is raining, the sky is cloudy. It is raining. Therefore, the sky is cloudy. So my first sentence, I see the key word if, and although I don't see then, I know the sentence is really saying if it is raining, then the sky is cloudy. So this really is a conditional. And I can let this first part, it is raining, be represented by the statement are. And I can let this second statement, the sky is cloudy, be represented by the letter S. And we hit our period, so that's the end of our first premise. So now we're on our second premise. Our second premise is it is raining. Notice that this is exactly like the first part of our conditional before. So our second premise is the statement are by itself. There are no keywords, so there's no conjunction, disjunction, conditional going on in our second premise. I do see the keyword therefore, and this tells me that I'm dealing with my conclusion. And my conclusion is the sky is cloudy. This looks a lot like our consequent from our first premise. And so that means our conclusion is our consequent. So we're going to start our argument exactly the same way as we've done our arguments before. I've listed my premises. I've listed my conclusion. What I'm not going to do is what we did with the truth tables. I'm not going to say are conditional as conjunction are implies s, and then convert that to a conditional and add the words is a tautology. I'm not going to do that because this is supposed to be a more concise way to prove an argument valid. What I'm going to do instead is come up with 2 simple columns. One labeled statements one labeled reasons. And in this column, I'm going to list the things that I know that are true. Now, I have two premises. And I'm just going to say the reason I know it's true is because it's a premise. The first premise is R conditional S, and my second premise is R. So that's my first statement, listing all premises. The second step in doing a two-column proof is I have to put two statements together using a conjunction. I have to take the conjunction of two statements. Luckily for me, I only have two statements. And I remember that when we talked about modus ponens, modus tollens, and hypothetical syllogism in our previous lesson, we always noticed that the conditional came first. So I'm going to continue that for step 3. I'm going to put my conditional first. And of course, the only other statement I have is statement 2, is my R. And these are statements that we know are true. And a conjunction is a statement that is only true if two given statements are true. So this is true because of conjunction. This really is just the conjunction of steps 1 and 2. And I want to know if this looks more like modus ponens or modus tollens or hypothetical syllogism. So I want to think in terms of my original P and my original Q. And what I notice is that R is taking the place of P. S is taking the place of Q. R, we said, was taking the place of P. So if I wanted to complete this argument, I would have to complete it with Q, but we know that S is taking the place of Q. And so what we really have here for our fourth statement is, because this implies Q, our argument in terms of R and S has to imply S. And our justification is modus ponens. Now the thing is, I'm never going to actually write this. I'm just showing it for demonstration purposes of what's actually substituting here. In reality, this is my argument. And because I've reached the conclusion, my argument is valid. So we went through the first 3 steps. We didn't have to do the fourth step where we repeat because I immediately reached my conclusion. In our second example, we have if it is raining, the picnic is not canceled. So my first premise says if it is raining, the picnic is not canceled. My second premise says if it is not raining, that's the negation of what I have here, the soccer game is not delayed. But the picnic is canceled. Now notice that but the picnic is canceled is the negation of this statement. The picnic is not canceled. So I really need negation C here. Therefore, the soccer game is not delayed. The soccer game is not delayed is exactly the same as this one. So it's plain D. So I've got three premises here. It's a little bit different than what we were doing before. It's going to require some thought as to which statements are going to get put together. What we need to do, though, is start our two-column proofs exactly the same as we've done before with our statements and reasons. And of course, my first step is to list my three premises. I've got R conditional C. I've got negation R, conditional D, and I've got negation C. And my justification, my reasoning for this is that they are premises. And that's the easy part. Listing my premises is very easy. What's more difficult is the second step. The second step is actually the most difficult part, and it's determining which statements do I put together. Because I've got three statements that I need to put together, and if I'm using a conjunction, I can only put two of them together at a time. And of course, I'm really looking for letters that match. And so part of me sees this R here that matches. And part of me sees this C that matches. And so the question is, which one am I going to be putting together? Am I going to be putting the R's together, or am I going to be putting the C's together? And here's the thing. If I guess wrong, I'm going to try and match it up to modus ponens or modus tollens or hypothetical syllogism. And of course, I'm leaning towards hypothetical syllogism because I've got two conditionals. But I run the problem that I don't know if C is supposed to be taking the place of Q, or if negation R is supposed to be taking the place of Q. So I have no idea which one's supposed to be. It's not very consistent. So that means that's probably not the best way to approach this problem. What I should do instead is try and put a conditional with negation C, and I notice that these letters match. So I've got R conditional C and negation C. So all I'm doing here is I'm doing the conjunction of 1 and 3. And if I'm thinking about what this looks looks a lot like P conditional Q. And if P is being replaced by R, Q is being replaced by C, over here I've got negation C, which is really negation Q, and that looks like that implies negation P by modus tollens. So what I'm going to put here is I'm going to put modus tollens on step 4, but now I need to write this in terms of not P and Q, but R and C. So R conditional C, conjunction negation C, implies negation R. And that's the modus tollens argument. Now, negation R is not my conclusion. And so this is where that step 4 comes in. If I don't reach my conclusion, then I have to repeat. But one of the things I want to remark upon is that we used up statements 1 and 3 when we came up with 4. And we used up statement 4 when we did statement 5. So I only have 2 statements left to really reflect upon. Statement 2, which is a conditional, and statement 5, which is negation R. And when we look at modus ponens or modus tollens or hypothetical syllogism, the conditional always comes first. So I'm going to do negation R, conditional D, conjunction negation R. So all I'm doing here is I'm doing the conjunction of 2 and 5. And of course that's using up step 2, that's using up step 5. And I'm looking at this to see if it matches modus ponens or modus tollens or hypothetical syllogism. If that's P conditional Q, negation R is being replaced for P. So this is really just P, and this is supposed to imply Q by modus ponens. On step 6. So what we've got here is we're really replacing, in terms of negation R and D, well, our conclusion was Q, which for us is D. And this is our argument. Which is valid. It's this four-step process that's going to enable me to prove arguments valid. Notice that this argument had three statements, R, C, and D. So our argument would have had 8 rows. But in the process of the 2-column proof, I only had 7 rows. So, as I mentioned at the beginning, this is a more concise way of proving arguments valid. I do have the shortcoming that, one, it's often difficult to determine which statements to put together. I do want to look at those letters that match, but also realize that I can experiment, I can try, and not be afraid to fail, because I can always erase. And 2, this only works if the argument is already valid. If it's invalid, I'm not going to be able to get anywhere. And we'll talk a little bit more about that in future episodes. It's the 4-step process, though, that's really important, though. The first thing we have to do is list all of our premises. And that's always the easiest part. The second part, and this really is the hardest part, is to take the conjunction of 2 statements. Just realize that we're always going to want to put the conditional first and something following it. It's deciding which conditional, if we have more than one, and which statement that follows it if we have more than one. That's the hard part. But the idea is that if I think to myself, what's replacing P, what's replacing Q, then the question is, what does this replace? And I want to try and match it to modus ponens or modus tollens or hypothetical syllogism, because I'm just going to write the conclusion, and I'm going to keep going until I reach the conclusion of my own argument. So I need to repeat steps 2 and 3 until I'm done. So this is a basic introduction to two-column proofs. Those students who will be going on to a geometry class will be seeing a lot of two-column proofs, and of course, when you go to college and you're trying to prove both mathematical equations and logical arguments, you're going to need to have this system of justifications behind you. So these two-column proofs, they're a more concise way to do it, and they'll eventually be a much easier way to prove statements are valid arguments. So once again, this is Mr. Potter. Thanks for watching. See you next time.